So an important feature that a planet may or may not have, and it's actually ends up being protective, is something called a magnetic field. In order to understand a planet's magnetic field, we can start with actually a regular old bar magnet. And so we see a north magnetic pole and a south magnetic pole on this bar magnet, the black thing in the center. And then can you see those kind of invisible pink lines? That would be the invisible magnetic field associated with this particular bar magnet, okay? And you can kind of see how, and it reminds me of those, you've ever seen those little games where you can give the guy a mustache and give the guy eyebrows and stuff with little metal filings and a magnet? That's what this reminds me of, okay? So magnets create a magnetic field. Well, we can create a magnetic field without a magnet. And to do that, it's coming, I promise. What we need to do is actually get charges chasing each other in a circle. And so if we kind of look at what this is a battery here, okay? And one thing that batteries are good at doing are, if you take a battery like this and you connect up a wire from one end to the other, what will happen is basically electrons will flow out and then back in. And so you kind of see actually electrons, there's an arrow showing it going out, and electrons are coming back in, okay, that kind of copper wire. So meantime, with that copper wire with the electrons chasing each other is in a coil right there, okay? So that's significant. Basically, if you can get charges chasing each other, okay, as this battery does with this wire kind of coiled in a cylinder, then you create a magnetic field. Is that not cool or what? Okay, so charges chasing each other. Well, in lies charges chasing each other with regard to ooey-gooeyness within our planet. So I know it's kind of small, but can you kind of see now the gray area kind of showing two regions within the gray area, the solid inner core and the liquid outer core. In the gray area and the liquid outer core, actually there are little tiny convection cells. And the fact that it's fluid, though, means that charged species in that fluid, as the Earth spins, charges are going like this as the Earth spins, okay? So here's the deal. The Earth then, can you kind of see the pink going out like that? That is our magnetic field. On the next slide, I'm switching from terms from that's our magnetic field to that's our magnetosphere. It's the same thing. It's protective and it's created by the liquid in the Earth's core rotating as the Earth spins, okay? So two criteria in order for a planet, if it wants to have a magnetic field. I just kind of mentioned them. First is it needs to be ooey-gooey in the center, can't be solidified, and the other is it needs to be rotating, okay? So it gets those charged particles moving, just like the battery got the charged particles moving in a circle in the middle slide. So here actually then, at the center of this kind of ghost-like looking thing is the Earth, okay? And this ghost-like looking thing is our magnetosphere, Earth's magnetic field. And then can you see over here on the left, basically the sun, they're showing the sun sending charged particles, nothing personal Earth, it's sending charged particles in all directions. We said that it has something called solar wind, it has radiation going in all directions, and actually the solar wind has charged particles that if they were to go ahead and hit the Earth's surface, it would play havoc with life. So can you see where the ghost magnetosphere actually deflects the majority of that harmful charged particles from the sun, coming from the sun? So is that not cool or what? Just to kind of point out, though, I don't know if you can see them, there are, and we are looking at kind of a cross section. The Earth is in the middle and the magnetosphere is going out like this. There are two or a couple, I think, kind of donut-shaped regions kind of close to the Earth where charged particles get trapped. And we actually, I prefer the name Van Allen belts, after Dr. Van Allen. Okay, and so actually these, how do I say, they are where some particles go to live that were kind of intercepted by the Earth's magnetosphere. Well, sometimes the Van Allen belts can't accommodate all of the little particles that get in. And so when that happens, if the Van Allen belts are basically full and the sun's being kind of rambunctious, and we'll talk about the solar cycles and how the sun can kind of be rambunctious and send an extra dose of charged particles. Then what happens basically is charged particles are not deflected, they're not trapped by the Van Allen belts, they basically cascade and fall down at the poles. These would be the magnetic poles. So we get our northern lights, and we would get southern lights too. Okay, so that's kind of how that works.